Hello friends, welcome to our next session. In the previous sessions, we have seen about the doubly linked list, details and the pros and cons of it. And now we'll see how a node can be inserted into a doubly linked list. So there are four possibilities, or can say five possibilities of inserting a node. Maybe a node may be inserted at the beginning of the doubly linked list is equivalent to the push operation, or it can be inserted before any given node, or it can be inserted after any given node, or it can be inserted at any particular position, and finally can be inserted at the end of the linked list. So let's begin our journey and see how we can insert in the beginning. So we have a linked list example here, which is made up of three nodes having values 2, 3 and 4. And in the beginning, the node with value 3 was the head. Now we want to insert a new node with a value 1, which is supposed to be the new head of this linked list. That means we want to insert this before 2. So what is to be done? So before insertion, we had a linked list. Head was pointing to the node with value 2, and the previous of the node value 2 was pointing to null. That means there was no more previous. So what are the activities to be done? Number one, we need to create a new node, and the next of this new node should be same as head, because head is the this particular node which is being represented. So the next of new node should be the head, and then the new node should be previous of the node that is currently called head. So this node is called head. So head's previous should be equal to the new node. So we create this one, and then we say that the previous of the new node is null, and finally we call this node as the head. So just like at a code. So we are inserting a node at the beginning, and we are creating a function. So where two parameters are passed on, that is the pointer saying where the linked list begins, and the data which we need to put in into the inserted node. So first we create a new node, allocate the memory for that, and then we add the value to the new node. So just copy this data into the data field of the new node, and then we say new node's previous is null, so we are taking up this one, and then we say new node's next is head. So new node's next is the head, so we create this link, and then we say if the head is not null, because if such a node exists, only then we can create a previous and all that. So the head's previous should be the new node. So from this node we create this link. So previous to this node is now the new node, and the head is now the new node. So from now onwards, this new node will be the head. So that's a sequence of activities done. So first we create the new node, add the data to that, then create a previous link as a null, so that we claim that this doesn't have any previous node, and then the new node's next is what we call the node called head, and if head exists, then we create this backward link, that is the heads previous is same as the new node, and now onwards this new node will be called head. So head will be pointing to the new node. So looking at the way it is being executed, so we have a node which has got three components: data, pointer to the next node, pointer to the previous node. Then we have a function to create the node. Then we have insert at the front. So we create a new node, and then new nodes next will be the head. And if the head is not null, then heads previous is the new node. So with this one function is used to print all the data in the doubly linked list in the forward direction. So for an example, we create the node as we discussed. So we have one doubly linked list having nodes 2, 3, and 4 values respectively. So create a node, call it head with a value 2, then heads next, create another node with a value 3, then heads next previous. So create a backward thing which is pointing to the head. Then next will be another node created with a value 4, and from 4 to 3 another backward link is created here, and then we just display the linked list, and then we just insert a 1 at the beginning of the linked list. So we just forward the position of the head, and then what data to be inserted. The data to be inserted is 1, and after inserting we just print it. So just look at what happens. Yeah, so the original list was 2, 3, 4, and after 1 is being inserted at the beginning, now it becomes 1, 2, 3, and 4. So let's just modify and see. So instead of inserting 1 at the beginning, if we insert 10 at the beginning, what we could get? Yes, 10, 2, 3, 4. So that's what we get from the this code which is trying to insert at the beginning. Now let's continue. What if we want to insert a node before any given node? So here we are trying to insert a node before a node having a value equal to 3. So the key is given as 3, and what we want to insert is a node that contains a value 2. So this is the logic. So how we can do? So first thing is we create a new node, add to do that, then go to the next node, and from the next node the previous should be your new node, and new nodes next should be this node. So these two links are created. So we have to go from here till here, and then create this link, and from here create this link to the new node, and from the new node back is the previous node. So how we are doing that? Let's check it. Then we have another example where we are inserting after the node. So the key is 2 here. So here we have to insert one with 3. So when we are inserting at the 3, what we are doing is we go to the next one and then create these two links, then these two links. So that's how we insert it. So insert after the, we need to know where the previous node is and then the data. So if the previous node is null, then we say that it is not possible. Otherwise, create a new node and then new nodes data, add the data, then new nodes next, new nodes next. So this is the previous node. New nodes next is same as previous nodes next. So new nodes next is same as previous nodes next, and then new node previous is same as the previous node. So we have created new nodes next as the next of the previous node and new nodes previous as the previous node itself. And if the previous nodes next is not null, that means if this one is not the last one, then we need to add this link. So new nodes, this is new nodes, next is this one, its previous will be the new node itself. So we create this link. And finally, previous nodes next is our new node, and that's it. So let's check these two activities. So let's first try to insert before a node, then see. So here we are trying to insert before a node. So till we reach the node, we just keep on moving. So we start a dummy pointer initially pointing to a head, and then if that pointer is not pointing to null, then we just check what data it is having. If that is the key, then we break. If it is not the key, then we keep moving forward. So till we reach the value key, we keep moving, and once we get the key, we break it. And if the current is null, then we just return the head, or we create a new node, and then the new nodes previous is current nodes previous, new nodes next is the current node, and new nodes the current nodes previous next is the new node. So these activities we do. And then to show an example, we have created a doubly linked list with nodes 1, 3, and 4, and we want to insert before node 3. So we want to insert a value of 2 before node 3. So head where the linked list is starting. So which node you are targeting. So the node is a node with value 3, and what to insert, we want to insert a node before this node having the key value, and in that the value should be this data. So that means it's the current linked list is 1, 3, 4, and before 3 we want to insert a 2. So before insertion, we print it, we see that it is 134, and after insertion, we see that before 32 is inserted, so it should become 1234. Let's just execute and check what we get it. Yeah, before it was 134, and after inserting node with data 2, before 3, we are getting 1234. So before 3, we had inserted a 2, Instead of before 3, if you had inserted before 4, we could have got 1, 3, 2, 4. So let's check. So before 4, if we had inserted, what would have happened? So it is 1, 3, 2, 4. 2 is inserted before a node whose value is 4. Now let's check it. What would have happened if we try to insert after the node? So we are just reaching the node till we get the node containing the key element. So once we reach there, then we do these adjustments, and we see that the example creates 1, 3, and 4 as a linked list, and after 1 we are inserting a 2, so we should get 1, 2, 3, 4 instead of 1, 3, 4. So if we just execute this and see that after 1, 2 is being inserted, so now we get 1, 2, 3, 4 instead of after 1. If you insert after 3, then we should get 1, 3, 2, 4. Yes, we are getting 1, 3, 2, 4. So that's what we are talking about when we are working with insertion at any position. Then insertion at any given position, then we just keep incrementing. So we start with the head with a position as 1, then go 2, then 3, and then 4, and so on till we reach the position. So it says that at the position number 3 we want to insert. So after 2 we stop. That means position -1. So till we reach position -1, we keep forwarding in the linked list from the head, and once we reach there, these adjustments are done. Then finally, looking at what could happen if we try to insert the node at the end of the linked list. So end of the linked list, the simple thing. So go till the end and then make a new node, and next of the last node is pointing to the new node, and make adjustments that new node's previous points to the last node, and finally the next of the last node should be made null. So here what we are doing is we are creating a new node, and data in the new node is writing, that is a 4 here, and then the new nodes next we are making null by default, and new nodes previous, if head is null, then that's going to be the new node or the first node in the linked list. So just to say previous is null, and then that you call it a head. Otherwise just go to the last node. So start from the head and keep moving till you reach the last node. So once we reach the last node, so the last node's next is the new node, and new node's previous is the last node. So that's how we can insert it. So just try to run this example and see what would happen. So here we have that logic. So till we reach the end, we keep moving, and when we reach, then we say current's next is the new node, and new node's previous is the current node. So here we are inserting 1, 2, and 3 as the initial 3 nodes while creating the doubly linked list, and finally we try to insert 4 at the end of it, and then before inserting, we just see that it is 1, 2, and 3, and after inserting, it should become 1, 2, 3, and 4. Let's execute and check what we get. Yes, it was 1, 2, 3, and now it is 1, 2, 3, and 4. So instead of 4, if I insert say 40, then I should get 1, 2, 3 followed by 40. 1, 2, 3 was the initial thing, and the last element we have inserted, and that is we can call as appending. So inserting at the last or the tail end of the doubly linked list. So we inserted 40. So we are now getting 1, 2, 3 followed by 40. So these are the four different ways of inserting any node. So the next session, let us see how we can insert the how we can delete any element from the linked list, or to be precise, doubly linked list. Thank you.